Okay, so this will be the next video, just dealing with sections 3.5, 3.6, and 3.7. And so more in terms of doing differentiation. And so far, everything we looked at has been in the form of y equals something, whatever that is. Okay? But what happens if we wanted to find a derivative like this? So now we get this 5xy plus 8y squared plus 12x equals 6x squared minus 5. And we want to find the derivative. Well, in terms of this one, we really can't take this and solve it for y. But we still want to find the derivative. Okay? So the process for this type, then, is called implicit differentiation. So all the rules we've seen so far still apply, so we're going to still use the same rules. Product rule, quotient rule, power rule, laws, derivatives of trig functions, and so on. And when we take the derivative of y, we get dy dx. So let's go through how I would find the derivative of this. Right? So we have 5xy plus 8y squared plus 12x equals 6x squared minus 5. Right? So, step one. We want to take the derivative of everything with respect to x. So I look at this first part. This is product rule. And so let's actually break that out into the pieces here. So let's say the first piece is 5x. The back piece is y. Derivative of 5x is 5. The derivative of y is dy dx. Right? So then I just took this, broke it out like we did before when we talked about product rule. And so let's do that part. And we end up with 5x dy dx plus 5y. So that's the first piece. 8y squared, well, this will give you 16y, and then dy dx. And actually this should be a 12x. Let's get the x back in there. Make sure you get it. And so the derivative of 12x is 12. And then the derivative of this piece will be 12x. Okay. So first step, take the derivative of everything with respect to x. Again, all the rules apply that we had before. And so we get this piece. Right? Step two. We want dy dx terms on one side and everything else on the other side. So basically after step one, this step is the calculus step. The rest of the steps we're going to be doing are algebra steps. So let's rewrite what we had here from this step down here. 5x dy dx plus 5y plus 16y dy dx plus 12 equals 12. Right? So what I'm going to do is I'm going to keep the dy dx's on this side, and so I'm going to take these two and I'm going to move those over there. Again, there's algebra, so we're going to subtract 5y, we're going to subtract 12, we're going to subtract 5y, and we're going to subtract 12. Okay? So when we do that, we get 5x dy dx plus 16y dy dx is going to equal 12x minus 5y minus 12. Okay. Step 3. Factor out dy dx. So now we're going to just factor. So dy dx was common to my two terms here. So we take that out. We're left with 5x 16y equals 12x 5y minus 12. And then step 4 is divide. So now we're going to just divide. And so let's rewrite this. We got dy dx 5x plus 16y equals 12x minus 5y minus 12. We want to divide, so we divide by this. We do the same thing over here. And we end up that my derivative, dy dx, is going to be 12x minus 5y minus 12 over 5x plus 16y. And now for this one of this type, if I want to know the slope, I actually have to know a particular point in terms of the x and the y value. And then I get the slope at that point. Okay? Other types of derivatives they talk about is you get in terms of derivatives of natural log and log functions. Right? So the derivative of natural log, e dx of ln x, is 1 over x. And the derivative of log base a. So this could be log any base, whatever that number is. Okay? And this will be 1 over x natural log of a. So, for example, one of this type, we want to find the derivative of this. And let's do y equals sine x natural log of 2x cubed. Right. So it's dividing, so that's quotient rule. So we divide it out. We get sine x. My g is going to be the natural log of 2x cubed. Derivative of sine is cosine. Derivative of the bottom piece is going to be 1 over 2x cubed. But then, like we saw before, in terms of the chain rule, we need to take the derivative of this. And this will give us 6x squared. So this will become 6x squared over 2x cubed, which will simplify to be 3 over x. Right. So now that we got our pieces, let's write our derivative. And so y prime is going to be the top term, which is natural log 2x cubed, times the derivative, which is cosine x, minus sine x, times 3 over x over the bottom term. Squared. And we get that. And like we said before, we will just leave it in the form. So we get in terms of derivatives. In terms of dealing with the logarithm, you get to another process, which is called logarithmic differentiation. So now we have something that looks like this: y equals x squared 2x to the 5th plus 7x raised to the 9th over x plus 3 to the 4th power. And so in terms of this process, the first step is to take the natural log of both sides. So we get the natural log of y is going to equal 2 ln x plus 9 ln 2x to the 5th plus 7x minus 4 natural log x plus 3. So the other thing that comes into play are all the various rules we had before in terms of logarithms: power rule, product rule, quotient rule. Next step is to take the derivative. So now we're going to take the derivative with respect to x. And so when we do that, we get this will be 1 over y dy dx is going to equal 2 times 1 over x plus 9 times 1 over 2x to the 5th plus 7x. And then the derivative of this piece is 10x to the 4th plus 7. Minus 4 times 1 over x plus 3, and then the derivative of x plus 3 is 1. Okay. So now let's go through and do a little simplifying here. So we get 1 over y dy dx. This will be 2 over x. Combine that a little bit. We can combine this stuff up together, okay, of it if we want. And so we could say that 9 times that is 9 dx to the 4th plus 63 over that. And the back term becomes minus 4 over x plus 3. Right? So we get that. We want to solve for dy dx, so the opposite of dividing by y is to multiply, and we end up with dy dx is going to equal 2 over x, 9x to the 4th plus 63, 2x to the 5th plus 7x, minus 4 over x plus 3, all of that times y. And at that point, we're done. So basically that's it for in terms of new material in the 2 sections for today. The last section of today, deals with some application type problems, and we'll do one example of those. And so let's pull that in here. And again, this comes out of the book. So you got this equation in terms of Q, which is in coulombs, dealing with the charge going through a wire. And so you got Q sub t is given by t cubed minus 2t squared plus 6t plus 2. We want to find the derivative. So we want to find d cubed dt, which will be 3t squared minus 4t plus 6. And now we can find out in terms of the how much current is going through. So Q over T is current. And so they want you to do it at 0.5 seconds and at 1 second. Right? So part A, when T equals 0.5 seconds, you get dq dt is going to be 3 times 0.5 squared minus 4 times 0.5 plus 6. And that comes out to be 4.75 amps. And then for part B, they want you to do it when T is 1 second. And so we would plug that in. And so dq dt would equal 3 times 1 squared minus 4 times 1 plus 6. And that comes out to be 5. So we've answered the question of those 2 parts. And with that, that will conclude this talk.